Okay, I'm going to show you now about superannuation. I'm just going to talk about it first. Have you heard of superannuation before? Yeah. So essentially, it's something that was brought in Australia back in, I think, the 1980s, where they made it compulsory for employers to actually contribute money to a fund to go towards your retirement. Because, you know, when people retire and they go on to Centrelink benefits or a pension, that actually costs the government a lot of money. So they thought, well, let's actually get that money, force people to save money over time. So currently the rate for superannuation is 9.5%. So that won't change for any of the questions. It's always going to be 9.5%. That's the rate that employers need to pay out of your income. So if you earn $100,000 a year, they're going to put $9,500 into your superannuation every year. And the idea is that you start that starts from as soon as you're employed, and it doesn't matter which when you switch employers, that money keeps building. And the idea is that because it's compounding over time and you work for a long time, you'll have a lot of money when you retire, and you can use that in part to live off, hopefully, for a number of years. And eventually, if you use it all up, then you can go on the pension. You can't usually get it before you retire unless there's some major catastrophe in your life. And that's why actually in the media at the moment they were talking about allowing young people to access their superannuation to buy a house. Now the problem with that would be then that their money wouldn't be compounding, and if the value of houses dropped, then that means they've really lost out on their money that they would otherwise have to save. You can also add money yourself, and if you didn't have any other things that you were saving up for, it actually makes sense to put money into your account, because if you put money into your account when you're young, it's going to be compounded many times by the time you're old enough to actually access it. So I'll go through an example here of how it accrues. We've got Joanna, she's 25 and she earns $65,000 per annum. Her employer makes quarterly contributions to her superannuation. How much will the employer contribute to the fund each quarter? So what we need to do here is we need to get the 65,000, because that's her income per annum, and we need to multiply that by 0.095, that's right, to work out what 9.5% of it is, and then we divide it by 4, because it's quarterly, okay? Christian, can you do that on the calculator for me? 1,543. And how many cents? 75 cents. Okay, and it's definitely 75, it's not 756 or whatever? No.
75.
All right, okay, great. So that's how much the employer is going to be putting in per quarter. And then the follow-up question for that, it says that her superannuation fund is earning her 6% per annum. So this is a savings account. She plans to retire at 65 years of age. How much money will be in her fund when she retires? So I guess we need to know how long is she going to be saving for? 40 years. Okay, how do we work that out? 65 minus 25. So that's 40 years. What part of the calculator are we going to use to do this? TVM, financial. So we've got N, I, PV, PMT, FV, PY, CY. N is going to be a big number because it's going to be 40 years times 4 quarters in a year. I is 6%. Present value will start with 0, okay? In a question, it might say that they've already got $20,000 in their superannuation account, and then you could put that number in there, but in this case, it's 0. The payment is going to be 1543.75. Make sure you put that in as a negative. The future value is what we're working out. Payments per year are 4, compounding per year 4. Okay, Christian, you've got that one? 1011501. Any decimal places? 68. Okay, I'll put some commas in there. Okay, so she's going to have $1,011,000 $501.68 in 40 years' time. So that's the power of compounding interest, putting in just over $1,500 every couple of months or every few months. She ends up with over $1 million when she retires. Okay. Now, $1 million doesn't sound too bad. Maybe when she's 65, she might live to 85. She's got 20 years to live with $1 million. How much could she have a year then? 50,000, I hear you say. Okay, so $50,000 a year is how much she could have then. In 40 years' time, what effect do we have to think about? Inflation, that's right. So $1 million now seems like quite a bit of money. But in 40 years' time, you're all going to be millionaires, okay, easily.